Hello, welcome to week 6 of Algebra 2 Accelerated Distance Learning Style. This week's going to be a little different. Hopefully you watched the expectations video that I posted. We're not going to have a normal formative quiz or normal summative quiz, like Schoology quiz, like we've been doing. It's a little different, but it actually, I think it's a little less instruction this week. We are going to be working on understanding the unit circle, and then from the understanding that we gain of the unit circle, we are going to memorize the unit circle. So the goal at the end of the day is to memorize the unit circle. If you do not understand or like the ways that I'm explaining how to memorize the unit circle, I'm going to post a few different videos from different math teachers online on YouTube about how they teach how to memorize the unit circle. So feel free to search on your own too and see what else is out there to help you memorize the unit circle. But I also think it's important that you understand where the values in the unit circle come from. And that's what we're going to focus on at first here. So we're going to go through our exploration, and that's going to help us understand where do these values come from and why do we have to memorize them? Why is it important to memorize them? So let's start. Instead of starting with a circle, we're going to just start with a length of twine, let's say. And we're going to say that the beginning, this twine has a length of 360, just like we have 360 degrees in the unit circle. And we're going to go through and we're going to mark the middle and then quarters and then all the different little parts that you would see in the unit circle. So halfway through this piece of twine, we are at 180, right? This is 0. And then after that, we want to look for the quarters. So quarters would be halfway between there and there. Now I'm going to let you guys try this on your own. I'll pause and then come back. But quarters, remember, you just divide by 4 and then add those values in. And then I want you to do eighths as well. So eighths are halfway in between the quarters, right? Okay, so here's the magic of the iPad that really comes in handy here. Once we do all those, we can kind of squish this and move it aside. And then we're going to start over, and we are going to do in a different color so that it is easier to maneuver with. And we're going to write them on the bottom. And we're going to do, and this one, it should say thirds in there. Hopefully on your sheet, you'll see that it says thirds in there. We're going to break this up into thirds. Now, don't worry about getting it perfect. Part of the reason why I wanted you guys to do this is because you're practicing your visualization skills and you're practicing your estimation skills. And so it's really good to get some practice with this. So to find the thirds, you would just divide by 3, right? And then we also want to do sixth, which is this half of a third. And then we also want to do 12ths. All right. So you're going to write down all the different degrees that are there, and you're going to do the same with the black marks that we just set aside, and then you're going to come back and check your answers. Okay. So take a second and try that on your own. Try to mark the different measurements and then come back and check them. All right, so hopefully you guys were able to have some success with that. And notice that these are the different degrees that are on the unit circle, on the key points that we talked about last week. Okay, let's do that same thing again, but we're going to imagine that the piece of twine is now 2 units long, kind of like radians, right? But we'll get there. And so we're going to do the exact same thing. We're going to start at 0 and we're going to go to 360 and we're going to cut it in half, and then we're going to cut that into quarters, and then we're going to cut that into eighths. And then we'll finish that, and then we'll go through and we'll do the thirds, which again is missing here, but it should say thirds in there. And then And then you'll do the 6th and the 12th and combine them together. So, oops, this is not 360. My bad, guys. This is 2, right? We're doing a length of 2. So, for example, half of 2 is 1, and then half of that would be 1/2, right? You want to use fractions. Please do not use decimals. All right, so have fun trying to mark up this piece of twine into all the different parts. And I will be right back with the answers. Okay, so I hope that was challenging, but also educational for you. Let's talk through this one because it's related to radians, and it leads into the next one, which we'll also do together. So notice here that when I cut it in half, right, we would get 1 for both, and then half of that is the same. Oops, that did not match up at all. Okay, let's change this one over a little bit. Sorry, they just didn't match up, so that would be 1/2 there. That's all right. We're eyeballing it, right? And then so this one matches up here. And so let's take a look at the different fractions as we go from one end to the next. So really, every single one of these tick marks is 1/6 of the unit circle. I know they're not exactly right because I eyeballed it and did it estimating. But if you go from 0 to 1/6, you're adding 1/6. If you add another 6, that would be 2/6 or 1/3. 3/6 is 1/2, and so on and so forth until you get to 1, which is 6/6. So we can do the same kind of thing if we looked up at the fourths, right? The eighths really is what we're cutting it into. We go up 1/4, and then we would add another fourth to get to 1/2, and then another fourth to 3/4, and then finally a fourth to get to 1. So something to keep in mind is that you're really always going up by the smallest amount each time, but because you can reduce the fractions, the denominators change. All right, and so these are all sixths down on the bottom. But our whole is actually 2, right? So here we would add another 6 and 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 another 6. Something to notice is some of these numbers have a pattern. You notice maybe that this is 5/6 here and this is 7/6 here. You're on either side of 1, so you have 1 less than 6/6 on the left-hand side, and you have 1 more than 6/6 on the right-hand side. Same thing with the fourths, right? So on the left, you have 1 less than 4/4, which is 3/4. And then on the right-hand side, you have 1 more than 4/4, which is 5/4. Also kind of interesting here, right? If you got to 2, that would be 8/4. 8 divided by 4 is 2. So 1 less than that, 1 right before you get to 2 would be 7/4. And similar with the 11/6. 12/6 is 2, so 1 less than that is 11/6. And this applies to the other fractions as well, but we'll take a look at it a little more carefully as we start to put together the unit circle. So what I'd like you to do for this next one is essentially we're going to do the exact same thing we just did, but we're going to instead add in the pi, okay? So I'm going to cheat a little bit here, and I'm going to take this whole thing, copy it. I'm going to paste it. Took a little bit extra there with that arrow, so I'll erase that. And it says it's got to be 2 pi instead of just 2 now. So all that changes, and I'll pick this dark blue color, is that every single mark has a pi with it now. Oh, this one we lost the 6's on this one. Oh wait, they're not all 6's. We lost 5/3, 3/2, 4/3. There you go. Um, and so instead of redoing all of these, we're just going to rewrite them with pies now. So it's 11 pi over 6, 5 pi over 3, 3 pi over 2, 4 pi over 3, 7 pi over 6. And so hopefully what you're realizing is that the pi is just getting treated as a variable. It's like an x. And so, we can treat it just like it is on the top. Oh, lost their 3 there. It is on the top of the fraction. Now, when we get down to the ones, we don't actually want to have this written as 1 pi over 2. We are going to rewrite it just as pi over 2. So keep that in mind. We don't want to write 1 pi or put the pi on the side. We want it to be the only thing in the numerator when we are writing it. So, and then for the 1, we also just change it into pi. Instead of saying 1 pi, we just say pi. Just like if we had 1x, we would want to write it as x to be a little more simplified. Okay, so the reason why I had you do that is because now we're going to take that understanding and hopefully we're going to put it into the unit circle. So imagine in your head that you just took the twine that you just created, and it's actually the one with the degrees on it. So you're looking at this twine and you're taking the ends and you're taking the 0 and you're having the 0 start at standard position, right? What we learned about last week at the positive x-axis, and you wrap it all the way around a circle. So let's take a look at that. For investigation D, we're going to be starting here, right? This is where our angles start in standard position. We're going to be going this way, but instead of going, labeling them as we go around, I'd like you to try and use that same strategy we did before, where we mark the beginning, right? We mark 0, and we mark the end, which is the same spot, but just all the way around. And then we mark the middle, which is over here. We mark that with 180. And then we do a quarter, and then we go through and do the thirds and the sixths. So I want you to try to mark the unit circle just like we did with the piece of rope. But now imagine the twine is wrapped around the unit circle. All right, give it a shot, and then so pause the video, and then when you come back, I will go through the whole thing with you. Okay, so hopefully you paused and you tried it out. So what we're going to do is we're going to get our strategies going for how to memorize the unit circle, but also it helps us understand it. So then right after that, I'm going to mark my quarters, right? And I can start putting my degree symbols on here. And then I know this is 90 more because it's a quarter, so that would be 270 degrees. All right, and now instead of going and like I said, going through and doing them one by one, I'm marking all the values that I know here. So just like what we did when we were doing the previous one, we know that it goes up by the same amount every time. So it's going to be going up to 45. So this would be 135. And then on top of that, we would get, sorry, brain fart. So 225. And then again, 270 plus 45 would be 315. Okay, so now we have all the eighths. I know it looks like it's quarters, right? But it's actually eighths because we're cutting the unit circle into 8 equal parts. All right, so then now we're going to go through, we're going to do the thirds, right? So to cut the unit circle into thirds, it's already marked, and on your quiz, it'll also already be marked. So you don't really need to worry about getting it exact. But your thirds are going to be where 360 gets divided by 3. So that would be 120 degrees here. And then we get 240 degrees here, and then back to 360. All right, and then when you're cutting that in half, you get sixths. So half of 120 is 60, so there's 60 degrees. And then 60 on top of 120 takes us to 180, so we don't have to write that one again. And then 60 on top of 180 brings us back to 240, so we don't have to write that one again. And then 240 plus 60, we do need to write that one. That one is going to be 300 degrees. And then 60 more brings us back to 360. All right, last ones we need to write in, and it is the 30 degrees. And then this one is the 150 degrees. And then this is 180 is on top of that. So then half of, or 180, so that would be 210. And then on top of, we don't need to do one until we get to, let's see, this would be 330, sorry. 330 for our last marking. All right, so hopefully this is helping you understand where these values come from. It is all about going by halves, dividing by 2, or by thirds, right? Divide by 3. So let's try and go one step further, and let's do the radians now. Let's do those a little. For some of us, maybe a little more tricky, but for some of us, maybe this is a little not too much trouble for you. So we're still going to start at 0, and we're going to end at 2 pi. And then here's where I'm going to go through this with you, but I'd like you to try it yourself. So remember, halfway through is pi. Pi is the same as 180. So go ahead and pause the video and do your best. Try to mark all the marks with all the radians if you can, and then come back and we'll do it together. Okay, so hopefully you tried it. Let's do it. So I love doing this. So halfway, we're going to mark our next marks here. This is going to be pi over 2. Okay, and then on top of here, in between here and here, gets a little bit tricky, but you can think about it as you are adding pi over 2, or you're adding 1/2, right? So 0 plus 1/2 is 1/2. 1/2 plus 1/2 is 1 whole. And then if you add another half, you are at 3 halves, right? 3 pi over 2 is the same as 3 halves. So 1/2, 2 halves, 3 halves is the way to think about that. All right, let's do halfway between there. So we know half of a half is a quarter. So we're going to mark pi over 4 right there. And then same thing happens as we did before. You're just adding a quarter every single time. So this would be 1/4, 2/4, which reduces to a half. And then we have 3/4, which is 3 pi over 4. And then we have 4 pi over 4, or 1 pi right there. The reason why I wrote that down is because it can be helpful to write it down. And then we know the next thing we're at, is 5 pi over 4. And then again, I'm going to write it down, or I'm not going to write it down for this one, but one more would be 6 pi over 4, which reduces to 3 over 2. And then the next one is going to be 7 pi over 4, which makes sense because this would be 8 pi over 8, or over 4, to bring us back to the beginning, which is 2 pi. 8 divided by 4 is 2. And so this is 1 less than 8. You're 1 less pi over 4. All right, so let's now go through and we will do the thirds. All right, so remember the thirds were right here. This was our pi over, we're taking 2 pi, right? 2 pi is the whole thing, and we're dividing it by 3, just like we would have done 360 divided by 3. Okay, sorry, maybe the video glitched a little bit. I had to pause it and fix something. But now, another 2 pi over 3, past that, if we added another 2 pi over 3, we would be at 4 pi over 3, right? So 2 pi over 3 plus 2 pi over 3, just like regular fractions and combining like terms, we get 4 pi over 3. So this would be 4 pi over 3. So remember that we are at 3 pi over 3 here, and this is 1 less, and this is 1 more. That'll come back in handy in a moment. Okay, and then if you add another 2 pi over 3, you would be at 6 pi over 3, which is 2. 6 over 3 is 2. All right, so now half of that would be pi over 3. And we can see that this is halfway, so that's our pi over 3. And then we're adding pi's over 3 as we keep going. So again, this was 2 pi over 3, that's 1 less. This is pi over 3, that's 1 more. So it's making sense that we're straddling the one whole, right? You have the pi in the middle, and it kind of gives you an indication of where you need to be. All right, and then we get 1 more pi over 3 would bring us to 5 pi over 3. 5 pi over 3. All right, and then we're going to cut it in half one more time, and we're going to get our pi over 6. So our pi over 6 gets added. Again, as we add, we see that, pi over 6, and then it would be 2 pi over 6, which reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 reduces to pi over 3. And then finally, we are writing 5 pi over 6 because the next one would be 6 pi over 6. So we are 1 less than the halfway point. Okay, and then again, this would be 7 pi over 3 because it is 1 more than the halfway point. And as we come over here, we see that this is the final one. That would be 11 pi over 6 because it's 1 less than it would be if we were here, right? 12 pi over 6 is 2 pi. So it kind of indicates where we are. It's helpful to look at the pi and the 2 pi to help you figure out where you're at. Okay, so that might be enough for you today to work on. So feel free to stop here and get that practice that you need. So the practice that I am giving you, I'm giving you this sheet here. You can practice as much as you want. There are tons of, like I said, other ways to approach this, but I just wanted to give you the basics. So what your goal is, and I want you to start timing yourself. So I would hope that you would get down to maybe 2 minutes. That's the goal there. But 3-4 minutes maybe would be okay to fill out the whole unit circle with radians and degrees. So, maybe it's helpful for you to have like a key for yourself. So like you are going to write in all this first unit circle, and then you kind of peek at it like as you try to do the one on the right. That might be helpful for you as you start off. And then slowly but surely you start to do it without it. So I'm going to go through one more of these before not before you go, but just in case you want one more time explaining how do I get all the degrees and how do I get all the radians around the whole unit circle, and what's one strategy for filling it out. If you don't need this extra instruction, feel free. You don't have to watch this. I just like to give extra so that you guys have it if you need it. So let's start with degrees. I think degrees are easier for me because they are not fractions. Sometimes fractions are a little harder to think about. So I'm going to start with my 0 and my, I'm going to put the 360 here. Now, it doesn't really matter where you put the degrees and the radians, dotted line, solid line, either way is fine. All right, and then like I like to do, I'm going to come and cut everything in half. So then that's 90, and then this would be 270. Okay, and then half of 90 is 45, and then 90 plus 45 is 135, and this would be 225, and then on top of 270, that would be 315. Okay, so you can start to see this could start going really, really fast if you're putting in the effort. Now, here's where I change a little bit about the way I was explaining it before and the way I do it on my own. Once I do that, I look at this as 30 degrees, right? Pi over 6. And I just put in every single one of those next. So all these chunks all the way around the circle are exactly the same. So we have 30, 30 plus 30 is 60, 60 plus 30 is 90, 90 plus 30 is 120, 120 plus 30 is 150, 150 plus 30 is 180, 180 plus 30 is 210, 210 plus 30 is 240, 240 plus 30 is 270, 270 plus 30 is 300, and 300 plus 30 is 330. Oh, and I would encourage you to put your degree symbols on there. I'm just putting a dot because I'm lazy and I don't want to have to go through and draw a little circle. Okay, so not too bad there with the degrees. I feel like we could all do that fairly easily with a little practice. I think the radians are really the difficult part. So let's start with the easiest part of the radians, which is 0, and then you go to 2 pi. And then I still use that strategy where I cut in half first. So pi would be half, and then half of that is pi over 2, another pi over 2. So this is 1 pi over 2, and then 2 pi over 2 is just the pi, and then 3 pi over 2 goes there. All right, and then half of that. So this is pi over 4, right? 2 pi over 4 is, so 2 pi over 4 would be there, which is the same as pi over 2. Add another pi over 4, and we're ending up at 3 pi over 4, right? 2 pi over 4, 3 pi over 4. Now we're at 4 pi over 4, which is just a whole, right? 4 pi over 4 is the same thing as pi. And then we add another pi over 4. That's going to give us 5 pi over 4, one more than what we were at. So 5 pi over 4. And then adding another pi over 4 to that gets us here, which reduces to 3 pi over 2. And then on top of that, we would do another pi over 4, which brings us to 7 pi over 4, which would then bring us back around to the beginning, which is 8 pi over 4, which is 2 pi, right? So we can always think 8 pi is where we end, 7 pi is one before it. That's why this is 7. Okay, and just like I did with the previous example, I go through and I do all my pi over 6s next. So switch it up a little bit. So start with the 30 degrees, that's pi over 6. I'm gonna make this a little smaller so it fits. So pi over 6 is here. Okay, so then I know that 2 pi, this would be 2 pi over 6. However, that reduces to pi over 3. So this would be pi over 3 here. All right, and then I'm going to add another pi over 6. The pi over 6 would take me back to here, which would be 3 pi over 6, which is pi over 2. Then the next one is we would get 4 pi over 6, which is actually 2 pi over 3, right? We reduce the fraction and rewrite it. So we're going to move that over here. And then another pi over 6 added to that would be another pi over 6. Sorry. So we had this one was pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Now we are at 5 pi over 6, which makes total sense because this is 6 pi over 6, right? That back at the 1 pi is 1 whole, and so we're 1 less than the whole pi. Okay, and then we keep going. Pi over 6 again, we are going to get 7 pi over 6. Again, makes sense because it's 1 more than 6 pi over 6, 1 more than the whole, 1 more than halfway around. All right, and then we do another pi over 6. That would take us to 8 pi over 6, which reduces to 4 pi over 3. Add another pi over 6. Well, that's going to take us to 9 pi over 6, which is the same as 3 pi over 2. So that's there. And then we do another one. So this one would take us to, we're just at 9. So now we're 10 pi over 6, which is 5 pi over 3, right? 1 less than that, 5 pi over 3. And then finally, we're at the end, we have 11 pi over 6 for right there. And that makes sense because 12 pi over 6 would take us to 2, right? 2 pi. Okay, so I hope this going through this with me has been helpful. Again, if you want to watch some of the other videos where other people explain it differently, feel free. Otherwise, here's a good spot to stop and just practice, 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 memorize, 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 memorize all the radians and all the degrees because there's more to it. So you probably want to pause, get that down, and then come back maybe tomorrow and we're going to go and memorize the rest of the unit circle. So have fun practicing and then come back. Okay, I hope that you had some fun doing some practicing and memorizing all the radians and the degrees. So good on you for taking some time to do that. We're going to scroll down and we're going to go to the points now. So last week you used your skills of SOHCAHTOA to find the points of A, B, C, and lots of different points that you were given instructions about. So what we're going to do is we are going to break it down so that we have all of the unit circle points memorized. Now that might sound difficult, but really using those reference angles, those bow ties from last week, it's really just very symmetrical and using the patterns to help you. So we got this. But like I like to do, before we go into trying to come up with strategies for memorizing it, I want you to understand where these points actually come from. So you might recognize these cute little triangles. These cute little triangles are special triangles. And you might be wondering, what do you mean by special? Well, they have nice round numbers to them when we are finding the lengths of the sides. So this one is 45, 45. Remember, that's the same as pi over 4, pi over 4. And then this is 30, 60, 90. That one is the same as pi over 6, pi over 3, and 90 is pi over 2. So we could put that in if we wanted to. But let's take a look at this. Because these triangles, right, they are if we were to take this triangle right here, C, and redraw it over here so that we can have a better look at it, this is a 30, 60, 90 triangle because if this is 60 and this is 90, then to get to 180 inside of a triangle, you know this has to be 30, right? And then same for triangle A as well. If this one's 30, then this one has to be 60. And so they're essentially the same triangle, just tilted. And that's why we get those bow ties. Okay, so let's take a look at this 30, 60, 90 special triangle right here. So what our issue is why is this not that helpful? This is not that helpful because our unit circle has a 1 for the hypotenuse in all the triangles, right? That's the definition of a unit circle, is that this length here is always 1. And so the hypotenuse in our triangles is 1. It is not what it says up here, which is 2. But we know that similar triangles all have the same ratio of sides. So if I were to divide this by 2, divide this by 2, divide this by 2, then my hypotenuse would be 1, right? 2 divided by 2 is 1. And then that means that my triangle sides are just going to be half as big. So essentially, all we really need to do is know that this x side or let's look at triangle A first because it's set up the correct way. We know that the x side of our triangle is going to be square root of 3 over 2, or we could say root 3 over 2. That's what you're going to hear me say a lot. And then the next, the y value is 1/2. Now, if you remember when we were doing this on our calculators, we were using, let me get my calculator out here. We were using cosine to find the x and sine to find the y. Well, it just so happens that that still applies here. So if I did, let me make sure I'm in the right mode here. Yep, I'm in degrees. So if I did sine of 30, I get this nasty decimal. Why is it giving me that? Degree, okay. So let's try it again. So if I did sine of 30, then I get half, which is our y value, right? And then if I did cosine of 30, I'm getting this decimal. This should look very familiar. However, if we did root 3 and then we did divide by 2, notice I had to go outside of the square root to get the correct answer. I get the same answer there. So when we are doing our unit circle, we're not going to use the decimals, but it is helpful to know what the decimals are because it can help you later with checking your answer and stuff. All right, so since we know that the x is root 3 over 2, that means the x value of that point is root 3 over 2. And we know the y value is 1/2, so we put 1/2 there. Let's look also at this triangle here. It is the same triangle as we just looked at, but it's just flipped. So we know the x is 1/2 and the y is root 3 over 2. Okay, coming over here, that means that triangle C is root 3 over 2. Is 1/2, right? Because they switch. And then it's root 3 over 2 there. So that's going to be really helpful for memorizing the unit circle, is remembering that those 2 points are exactly the same, just flipped. Let's take a look at the values for our other triangle, which is this 45, 45, 90 triangle. Again, our unit circle has a hypotenuse of 1, not of root 2. And so in order to change this into a hypotenuse of 1, we divide by root 2. And this is where things are a little weird. Maybe you remember this from earlier in the year, maybe you don't. Either way, what we do is we do something called rationalize the denominator. So before there were calculators, it's really hard to divide by an irrational number by hand. And so what people did back in the day is they forced you to rewrite everything so that the denominator that you had was easy to divide by. If that was too much for you, it doesn't make sense, don't worry about it too much. Just know that 1 divided by the square root of 2, that's the same as the square root of 2 over, that is the same as the square root of 2 over divided by 2. Same decimal, same answer. Also, remember that sine of 45 is equal to points out same answer, and it should be the same as cosine of 45 as well, which it is because it's an isosceles triangle, right? It has 2 sides that are the same length. So in here, we have root 2 over 2. We have root 2 over 2 there. Okay, so that's where the points in the unit circle come from, more or less. There's a little bit more to it. And so let's just fill out these other parts. Remember here, this is the first quadrant. So your x value is 1, and you haven't gone up at all yet. And then here we have an x value of 0 because we're on the y-axis. And then you have a y value of 1 because you went up 1 unit. And then let's write in our degrees and radians. So 0, remember our smallest radian or degree that we go up by is 30. And then 45 is in the middle. And then our radians, 0, pi over 6, pi over 4, pi over 3, and then pi over 2. Okay, so if you understood that, great. That is all you really need to memorize for the points, right? We're talking specifically about the points right now. You already went through and memorized all the degrees and angles, so all the degrees and radians. So we're not worried about that part anymore. But let's take a look at how do we use the bow ties and the symmetry of the circle to complete an entire unit circle with the points. So I'm going to go down and I'm going to look at these beautiful bow ties here. So remember, this picture that we just looked at up here, this is the exact same thing as this chunk right here. If we were to flip it and have a mirror image, it's the same as this. Flip it down, same as this. Flip it over, same as this. Okay, so let's start with quadrant 1 and we'll work our way around and do the whole unit circle, and I'll kind of just explain how the symmetry works, and hopefully it'll be helpful. So I'm going to do my first triangle, or I'm going to do all the key points, all the corners first, because those I don't even need to know anything about special triangles. So I know this is 0 or 1, 0, and this is -1, 0, because we're on the x-axis. And then this is 0, -1, and then this is 0, +1. Now, you'd be surprised how many people make mistakes on those, because it's easy to just kind of forget which one's negative, or whether it's x or y that's working. So we will keep going here. All right, so I like to go through and make sure I mark what the different signs in the different quadrants are. So I know in quadrant 1, my x and my y are both positive. So I like to draw a little picture there. I know that in the second quadrant, my x's are going to be negative, but my y's are going to be positive. I know in my third quadrant, I'm going to have both negatives. And then I know in my fourth quadrant, I'm going to have a positive x and a negative y. And that's something hopefully that sunk into your brain from our lessons last week, is that when you're finding the point where in the coordinate plane that they need to be positive or negative. Okay, so let's take a look here. I'm going to go through and do all of the red bow ties first. So I'll do them in red. So our first point, notice that this is longer than this, right? Our x is longer than our y. Well, that reminds me that √3/2 is larger than 1/2, right? √3 is larger than 1, so therefore it's larger than 1/2. And then all I do is I just travel around the circle and find all the points that are going to be the same as that. So √3/2 and 1/2. I remember that all my x's are going to be negative in that area. I go down here, everything's negative down here, so I have √3/2 and -1/2. And then I'm going to do my last red part of my bow tie, which gives me a √3/2 and a -1/2 there. Okay, let's do the blues. The blues are nice because it's an isosceles triangle, right? You're just doing the same number twice. So it's just √2/2, √2/2. The only tricky part is remembering where the x's are negative or the y's are negative. So we're just marking all these points. √2/2, √2/2. Everything's negative there. Third quadrant's a real bummer. Everything's negative. All right. This is √2/2, and then √2/2 is negative because we're below the x-axis there. All right, we got our last one. It's going to be almost exactly the same as the red bow tie, except for you switch which one is X and which one is Y, right? Because it's the same triangle, just flipped. Sorry, my cat's running around a little bit here. 1/2 and then √3/2. Let's take the show on the road. We're going all the way around the circle here. Over here, we are going to get a, it is a 1/2 and then √3/2, but I know that the X is negative in that quadrant. Now we're in the bummer quadrant, -1/2, -√3/2. And now we are in our final quadrant, which always has, the 1/2 for the X and then a -√3/2 for the Y. All right, so again, that's a lot. I provided this place for you to practice all those points. So I would recommend that you pause here, you practice doing those points, just the points, right? And again, try to get yourself to maybe 3-4 minutes for putting all the points onto the unit circle. So your goal is that you're going to try and time yourself so that you have 10 minutes to do degrees, radians, and points. That's your goal. And that's what your summative is this week. You get to read the instructions for the summative, but that's what your summative is. There's also a formative quiz. It's worth points, but it's unlimited tries, and it's just a way to practice memorizing the unit circle. So it can help you memorize that as well. Okay, so that's pretty much it. There's tons of spots for you to practice. If you go to the summative, there's a really nice sized sheet for you to practice on. If you wanted to do it on Notability, that's a good way to practice. If you want to try and draw your own on a piece of paper and do it that way or print it out, you're welcome to do that too. Yeah, good luck. Feel free to watch the other videos that I'm going to post of other people explaining it differently too. So maybe if my way of explaining it is not working for you, it can help to look up a few other videos and see how other people do it. All right, have fun memorizing the unit circle. I cannot wait to get to do the memorization quiz with you kind of in person. So have a great week and feel free to email me, reach out with any questions that you have.